I recently posted a video on the proof of taking a derivative, but one thing I wasn't quite happy about was I didn't really show an intro on what the derivative does or why we use it. I wanted to keep the video short because there was just so much information, and so I decided I'm going to make a brief intro video to how to take the derivative and why we use them. And hopefully this will be a short video, and so if anyone cares, then they can see the next video, which is the proof of what I'm going to show here. I make very low quality, no effort videos, but the reason I do them is because for the most part, they're proofs that I couldn't find anywhere else. So while the quality may be low, I like to think that the information is golden. So in this case, the reason I'm making an intro video is because I like the idea that something can have a reputation for being famously complicated, but it turns out it can be broken down into baby steps into something so simple that somebody with just high school algebra could understand. So that's what this little project is right here. So this is the part one, or the intro to my derivative proof video. The reason we take a derivative of something is because we want the slope. We want to know how steep that line is. All slope is, it's represented as m. It's just your rise over your run, your change in y over your change in x, delta y over delta x. In this case, change in y is 1 right here. Change in x is 2. So it's just 1 over 2, or 1/2. That is our slope. Now where calculus comes in is, in calculus we're not dealing with a straight line where we can take a simple change in y over a change in x. If we're looking at something like a parabola, x squared equals y, if we want to get a slope on this point right here, this is actually called the slope of a tangent line to a curve, because it's the slope on how steep it is, and it's a tangent line because it just touches the curve. We can't really take a change in y over a change in x here because every point is different than the point just behind it and the point just in front. So in this example, I just showed a slope here is going to be different than a slope there. So here's how we deal with this using calculus. X squared equals y. By the way, I didn't draw this to scale, but oh well. What we want here is we want to get the slope of, say, this point right here, where 5 is. But we can't really take just a change in y over a change in x because this is a curve and it's not a straight line. So we take 5, which is our x value, take something like 6 right here. So this will be x plus h. In this case, 5 is just 5. This number right here will be 5 plus 1. So x plus h will be 5 plus 1. That's how we get our 6. Now we can take a straight line between here and here to get our slope. But that'll be just more of an average. We want something even closer. So what we do is we move this 6 in to like 5.5, 5.2, and then 5.1 right here. So 5 is right here, and we make this 5 plus 0.1, so 5.01. So now we're dealing with a very small distance between here and here, and we're zeroing in on that slope. Now we can zero way in, which is the difference between 5 and 5.001 on the x-axis. We take 5 and square it, we get 25. We take 5.001, we get some number that's slightly higher than that. We can make a table. X will equal 5, y will equal 25. X will equal 5.001, y will equal 5.001 squared. Now we can take our change in y, so it'll be this minus this over our change in x right here. And that'll give us some number of a slope that's reasonably close to this, but it's not exact. So this is where we use derivatives or calculus to get that exact slope on that point. Here's the same terminology right here, just x and x plus h. Now what we do here with a parabola is that's x squared equals y. So whatever we get here for x, we square it, and we're going to get x squared. If this is 4, we get 16. If this is 5, we get 25. And this will be x plus h. So this could be 5, and this could be 5.00001, something like that. So it'll be x plus h quantity squared, because whatever this value is, we square the whole thing. So this minus this divided by this minus this brings us to right here. FOIL this out right here. Actually, sorry, I should start with the bottom. X plus h minus x for our x value. Notice the x's here will cancel out, and you're left with h. Which makes sense because this is just change in y over change in x. So this is just the change in x right here, is just h. Now we go ahead and FOIL that out, and we're going to end up with an x squared right here and a negative x squared right here. The first and last term will always cancel. The second term will always have an h to the first power. That'll cancel out when divided by this h right here. And see my video on the proof of derivatives for the next steps on this.